Hello, everyone. You are welcome to Math with Mr. Olukorede again. So, if you joined my class yesterday, you are especially welcome again. And if this is your first time joining this platform, you're in the right place. You are welcome as well. So, today we are going to continue our discussion on mensuration. So, before we begin, I want you to get your writing materials ready, okay, because today's class is going to be interactive as usual. So, and don't forget to invite someone, your mates, okay, let them know the class have started. All right, so this is the first question we are going to be dealing with for today. Okay, so before we commence, let's see those that are available for the class. All right, once you just join, I want you to say hi to the class, and don't forget to tap the like button. All right. Okay, Toyosi, you're welcome to class. I can see you in the class. You're welcome. All right, now let's look at the first question here. Now, in a circle of radius 14 centimeter, a chord extends an angle of 120 degrees at the center. Find the perimeter of the minor segment to the nearest three significant figure. All right, now to answer these questions, we need to understand all the formulas that surround finding perimeter of a sector, a segment, and also finding length of a chord. So if you don't have all of these, make sure you go through or you visit my previous videos. So all of this has been done. All right, now let's look at it. Now, in a circle of radius 14 centimeters, so we are given 14 centimeters. Okay, a chord subtends an angle of 120 degrees at the center. So our theta, which is the angle, is 120 degrees at the center. Now the question wants us to find the perimeter of the minor segment to the nearest two SS. So we want to get the perimeter of minor segments to the nearest three significant figure. All right, don't forget, perimeter of the minor segment is the addition of the length of the chord and the arc. All right, so now let's write the formula out. We have perimeter of the minor segment is the length of the arc, which is theta over 360, okay, times 2 pi r plus the length of the chord, and that is what 2r sine theta over 2. Okay, so that's what we have. So when you had, a minor segment is like this. So if you want to get the perimeter, you had this length and this curve, which is the arc. All right. Now this arc, this is the formula for finding the length of the arc, and this chord, this is the formula. Okay. So now let us now plug in the values we have here. So we have our theta angle is 120 degrees. That is the angle subtended at the center, times 2 times 22 over 7 times the r, which is the radius. That is 14. We have 14 plus 2 times 14, okay, sine 120 over 2. I hope you understand that. All right, so now this gives us what? Now 120 goes here is 1. 120 goes here is what? Is 3. Okay, so 7 goes here 1. 7 goes here 2. So now this now turn to 1 times 2 times 22 times 2. That gives us what? 88. We have 88 over 3 plus, now you multiply 2 by 14, that is 28. Sine, now when you divide 120 by 2, you have 60. Okay, so now let's divide this. 3 goes in 8, that is 2. Okay, so we are left with 2. So 3 goes in 28 now, that is 9. It remains 1. So 1 over 3. Okay, so plus 28 times, now let's find what sine 60 is. So can you punch your calculator or you check your four-figure table? What is sine 60? Now if you have the answer, drop that in the comment section. So make sure you are participating. What is sine 60? Drop that in the comment section. Sine 60, check your four-figure table or your calculator. What is sine 60? Okay, Fayomi Ezekiah, you're welcome to class. All right, I can also see Esther, that should be Dorcas. All right, I can see Pamilerin and Rachel Mosho, you're welcome to class. Okay, so what is sine? Okay, we have is 0.866. 0.866. Okay, sine 60. Sine 60 is 0.8, so is 0.866. Okay, so now this is the same thing as 29.33 and so on plus, now let's multiply this times 28. What do you have? You have 24.25. Okay, now we can add that to 29.33. So when you add together, you have 53.578 in what? In centimeter. Okay, so that will be in centimeter. All right, so now the question asks you to find the answer to the nearest 3 significant figure. 3 significant figure, this is the first significant digit. So you count 3 from the first one, 1, 2, 3. So you stop here. So that means your answer is approximately 53.6 centimeter. So this is the perimeter of the segment. Okay, perimeter of the segment. Okay, so before we move down to the next thing, all right, if you have any observation or question based on what we have on the board, please drop that in the comment section. Any observation, any question based on what we've done? Okay. All right, if there's no question, okay, I can see Joseph. Okay, the same answer. We have 53.6 centimeter. All right, okay. Now let's move down to the next question. Okay, now can we see the next question? A chord of length 12 centimeter is drawn in a circle of radius 10 centimeter. Now find the perimeter of the corresponding minor segment to the nearest tenth. Yes, so we want to find the perimeter of the minor segment. Okay, can I just give you 2 minutes to attend to that question? It's just a replica of what we just did now. So let's try it, and once you have your answer, you can drop in the comment section. Okay, let's make an attempt. Once you have your answer, drop your result in the comment section. So I'll be waiting for Olajumoke's answer. Bamilerin, waiting for your answer. Olawale Gabriel, I'll be waiting for your answer. And Toyosi, I'll be waiting for your answer, and others. Okay. Okay, I can't see anybody drop in answer. Okay, so probably we need to solve the problems together. We need to solve the problem together. Okay. All right. Now let's look at the question. Now the question says a chord of length 12 centimeter. Chord of length 12 centimeter. Now let's put that down. The chord is 12 centimeter. Is drawn in a circle of radius 10 centimeter. So radius is 10 centimeter. Okay, you have to find the perimeter of the corresponding minor segment. Now let's look at it. We have a circle of this form, and we have a chord here. This is the center of the circle. All right. So now we have a radius coming down like this. It's just the shortest distance between the center and any part of the circumference. So now the length of this chord is given to be 12. That's 12 centimeter. This 12. Okay. So, and the radius is given as 10 centimeter. So what do we want to get now? We want to get this perimeter. This perimeter here. This is what we want to get. So that means we want to get the length of this chord plus the length of the arc. All right. So now let's write the formula out. But we have an issue. We need an angle here. Because if you don't know the angle here, it will be very difficult for us now to find the length of the arc. So now, can we get this angle here? Now, let's get this angle here. Okay, so now length of chord equals to 2r sine theta over 2. Now, this is the formula. Now, and the length of the chord has been given to be 12 centimeters. So now let's put it there. We have 12 centimeter equals to 2r. What is R? R is 10 centimeter. Okay, so we put 10 sine theta over 2. Now this is the angle subtended at the center of the circle, theta here, and that's what we want to get. Now, so we have, you can first divide both sides by coefficient of sine theta over 2. So that means we have 12 over, this comes here. So we have 20, because 2 times 10 is 20, okay, equals to sine theta over 2. You can simplify this one. 4 goes here is 3, 4 goes here is 5. So we have 3 over 5 equals to sine theta over 2. I hope you get that. So we can take arc sine of both sides. So if you do that, you'll be having arc sine of 3 over 5. What's that? That's 0.6. Okay, equals to theta over 2. All right, so now we multiply 2 by both sides. Multiply both sides by 2. So now we multiply this by 2 and this by 2. So we have 2 sine, arc sine of 0.2 equals to, so when you multiply this by 2, so 2 cancel 2, so we have what? You have that. Okay, so then we can now get this. Now we have 2. Now what's going to be the arc sine of 0.6? So you can make use of your 4-figure table or use your calculator. So if you are making use of your 4-figure table, so you just go to sign of angles and look for where you are going to see 6,000, because this is the same thing as 0.6000. And of course, don't forget your 4-figure table is in 4SF. So you look for where you are going to see 6,000. All right. So now that is where you are going to have the value. All right. So now, or you make use of your calculator. So here I'm making use of my calculator. I'll press arc sine of 0.6. So you just press second function sine. Second function sine. So you will see this arc sine there. Okay, and you press 0.6. So if you do that, what you have is 36.87. Okay, equals to theta. So you can just multiply that by 2. So if you multiply that by 2, what do you have? So you have 73.74 degrees. Okay, so this is going to be the theta, the angle. And what we need is not even the theta itself. What the question requires from us is the perimeter, this plus this. Okay, so now let us let's find the perimeter. Perimeter of a segment is length of chord plus the length of arc. So we now say, okay, perimeter of segments. So that is going to give us length of chord. What is length of chord? In this case now we have been given to be 12. So we have 12 plus length of arc. What is length of arc? Theta over 360 times 2 pi r. I hope you understand that there's no need for writing out formula again for length of chord, since the length of chord has been given to be 12. Okay, so this gives us what? 12 plus, now we already have theta now. So we have 73.74, okay, over 360 times 2 times 22 over 7 times 10, which is the radius. Okay, now let's find a way of reducing this. So now this 0 cancel 10 here. So now 2 goes here 18, 2 goes here 1, 2 goes here 9, 2 goes here is 11. Okay, so what we have now, here is 12 plus, now we have 73.74 times 11. Okay, everything over 9 times 9 times 7, and that is 63. Okay, so now we have 12 plus, now let's evaluate this. We can evaluate that making use of our calculator. We have 73.74 times 11. Okay, now everything divided by 63. Okay, so you have 12.875. All right, so now we can add. Now let us add. So when you add, what do you have? You have 24.875. Now the question asks you to correct to the nearest tenth. To the nearest tenth. Now this is 8 is in position tenth. Okay, so that means our answer will be approximately 24.9, because the next digit is up to 5. So you increase this by 1. So, and this is going to be 24.9 centimeter. So this is the perimeter of the segment. Okay, the minor segment. All right, so I want to believe that we all understand the explanation. So if you have any reservation based on what we have done before we move on, okay, so please drop your comments in the comment section. Your observation, drop your observation in the comment section based on what we have done. All right, any comments? Any observation based on what we have done? Okay, so if there's no question, no observation, I think we can proceed to the next question. Okay, now this is another question. I guess it's a simple question. All right. So now in a circle, the perimeter of the minor segment is 40. So the perimeter of the minor segment is given this time around. Not like the one we just did where we have to find perimeter of segment. So the perimeter of the minor segment is given to be 40 centimeter. All right, now the chord is 16 centimeter. The chord is 16 centimeter and the radius is 10 centimeter, the radius of the circle. Now the question now is find the angle subtended at the center of the circle to the nearest degree. Will you try this in 2 minutes before we solve the problem together? Let's try this. Let's attempt the problem. So once you have your answer, you can drop your answer in the comment section. Let's see what you have. So you need to read in between lines. Make sure you are doing something. Okay, anybody with an answer? Okay. Because of our time, we may need to solve this. Let's solve it together, but it's simple. So I expect a good number of us to have an answer to that problem. It's not difficult. Okay, now let's look at the question. So in a circle, the perimeter of a minor segment is 40 centimeters. So let me try and list all the parameters given. Now, perimeter of minor segments is given to be 40 centimeters. So I have this. And also the chord is 16 centimeter long. So chord is 16 centimeter. What else are we giving? The radius is 10. So radius R is 10 centimeter. Now the question now is find the angle subtended at the center of the circle. You understand now? This is the way it looks like. We have your circle. This is the center. You have a chord which length is 16 centimeter. And we have the radius. This is the center of the circle. What's the radius? 10 centimeter. Now the question now is we should find, 16. So we should find the perimeter of this segment. What are we have to find? No, the angle. Sorry, we have to find this angle. You have to find the angle subtended at the center of the circle. All right. So this has been given. This length of chord has been given. We have been given the radius. So we can easily solve that problem. All right. So what I'm going to write out now is the formula for finding the perimeter of minor segments. Perimeter of minor segment, because minor segment has been given in the question. So I don't need to find that. Perimeter of minor segment has been given, so I don't need to find that. So that has been given. So I'll write out that perimeter of minor segment is the length of the arc plus length of chord. So length of chord has been given. Can you see that? 16. So I write 16 plus what? That is length of arc. That is not given. So let's write out the formula for that. That's theta over 360 times 2 pi r. You get that? Okay, so now this is going to give us 16 plus, now theta, that is what we are looking for, the angle subtended, times 2 times 22 over 7 times r. The radius is 10. Okay, radius is 10. So now let's simplify this. We have, now this cancel this, 2 goes there 18, 2 goes there 9. Okay, we have this to be 11. All right, so we now have 16 plus theta times 11. Okay, so we have 11 theta over what? Over 63. Okay, but don't forget, we have been given what? The perimeter of the minor segment, that is 40. So we have 40 equals to 16 plus 11 theta over 63. So now let's subtract 16 from both sides. So subtract 16, subtract 16. So what do we have? 40 minus 16. So that is what? That is 24 equals to 11 theta over 63. So the 1. So we subtract 16 from both sides. Okay, so now you can cross multiply here. So we have 11 theta equals to 24 times 63. So you divide both sides by 11. So when you do that, we have theta equals to what? 24 times 63 all over 11. Okay, so now let's evaluate that. If you evaluate that, what do you have? Now you have 24 times 63 divided by 11. So you have theta to be equals to 137.45 degrees. So that's what you have. Okay, so now the question asks you to convert your answer to the nearest degree. So the nearest degree means to the nearest whole number. So what's going to be the nearest degree to this? Yes. What's the answer? What's going to be the final answer? Please drop your answer in the comment section. So what's going to be the final answer now to the nearest degree? So what's your answer? Okay, anyone? Yes, what is theta to the nearest degree? So you express 137.45 to the nearest degree. Yes. So I expect every one of you to drop the correct answer. This straightforward question. Yes, anyone? What's going to be the final answer? Okay, I want to believe every one of you are hearing me. Okay. Yeah. So what is theta to the nearest degree? theta to the nearest degree. Okay, so when the question says to the nearest degree, so we are saying to the nearest whole number. So I don't know why some of you are not dropping your answer. Probably maybe it's the network. No problem. So now the answer is going to be 137 degrees. Okay, so this is what we have to the nearest whole number. So this is the nearest whole number. This is not up to 5, so you can't approximate. So you have that. So that is it. So any observation based on what we have done. So drop your comments. Any observation? Any question? Yes, based on, right? Based on the question we just solved now. All right. Probably maybe the network is not friendly, but let's continue. Okay. So now let's look at the next question here. Let's look at the next question. Okay. Okay, yes, that is another question. Okay, so the area of a sector of a circle is 154 centimeters square and its radius is 14 centimeters. Find the perimeter of the corresponding segment to the nearest centimeter. Okay, let's see how you expect to solve this problem. Let's solve the problem together. Okay, now in the question, let's list what we are given. We are given area of a sector to be what? Area of sector. Area of sector to be equal to 154 centimeters square. Okay, and its radius is 14 centimeters. So we are given radius r 14 centimeters. Now the question asks you to find the perimeter of the corresponding segment. We want to find the perimeter of corresponding segments. So that's what we want to do now. So how do we go about this? Now the first thing now is I need angle here. Okay, so now let me use this area of a segment to get an angle, the angle subtended at the center. So now see, we have area of sector equals to theta over 360 times pi r squared. Now this is the formula for finding area of a sector. Okay, now the area of the sector has been given to be what? To be 154. So we have 154 equals to theta over 360 times pi is 22 over 7 times the radius. What is the radius? That's 14. We have 14 times 14. So that is what we have. So now let's find a way of simplifying this. So we have 7 goes here, 1, 7 goes here is 2. Okay. Now 2 goes here is 180. Now 2 goes here is 11. Okay. So now what else? We can see that 2 goes here is 90. 2 goes here is 7. All right. So we end up now having 154 equals to, now this 2 multiplies, the 11 multiplies 2 multiplies 7. So we have theta times 22 times 7, everything all over 90. Now with what we have here, can you tell me what theta will be? Okay, now we have to do this and tell me what theta is going to be. The answer to theta . Yes, yes, anybody? What is theta? Okay, I want to believe. Can you all hear me? Can you hear me? Yes, can you hear me? And can we all see the board? Okay, all right. Someone have dropped an answer. All right. Okay, that's good. Another person? All right. It seems the network is not friendly today. Okay. Okay, no problem. Yes. Someone has given an answer to be 90. I think that's supposed to be 90 degrees. Yes. So you cross multiply. Let's cross multiply here. So that's what we're supposed to do. We have theta times 22 times 7 equals to 154 times 90. So here you divide both sides by coefficient of theta. So that means theta will be 154 times 90 all over 22 times 7. Okay, so here we can say 7 goes there 1, 7 goes there is 22, and 22 goes there 1, 22 goes there 1. So we have theta equals to 90 degrees. So that is the angle subtended at the center of the circle. All right. So now let us now move forward. Now the question says we should find the perimeter of the segment to the nearest centimeter. So now let us now go ahead and do that. We know the formula for finding perimeter of a segment. So let's do that. All right, perimeter of segment, perimeter of segment equals to what? That is going to give us theta over 360 times 2 pi r plus what have you? We have the length of the chord, that is 2r sine theta over 2. Okay, so we have length of arc and the length of chord. So when you add everything together, it gives you the perimeter of a segment. All right. Okay, now let's move on to the next thing. So we can plug in. Okay, what is theta? Theta here is what we are looking for. We have, okay, we already have that to be 90, sorry. So we have 360 times 2 times 22 over 7 times, what is r? That's 14. Okay, that's 14 plus 2r, that is 2 times 14 times theta over 2, that's 90 over 2. Okay, so now can we evaluate this? So what do we have for this? So we have 90 goes here 1, 90 goes here is 4. Now 2 goes here is 2, 2 goes here 1, 2 goes here 1, 2 goes here 11. All right. So and 7 goes here 1, 7 goes here 2. So what we have here now is just 11 times 2. That's it, over 1. So we have 22 because 11 times 2 is 22 plus, now let's see this is 28. We have 28 sine 45. Now we have sine 45 because 90 divided by 2 is 45. So you can punch your calculator and get what sine 45 is. It's the same thing as square root of 2 over 2. But since the question wants us to express it in nearest centimeter, that means it must be in decimal form. So we have 22 plus, now what do we have for that? Sine 45. Okay, can you tell me what is sine 45? Can you drop that in the comment section? What's sine 45? Check your 4-figure table and drop your answer in the comment section. What is sine 45? Sine 45 is what? Sine 45. Oh, Olajumoke, is it 137? Are you sure that is the answer? Sine 45. Sine 45. Check your 4-figure table. Check sine 45. 45 under 0. Sine of angle. Okay. So what do you have? Sine 45. Anybody? Okay. Now, if you check very well, should be having something like this. We have 28 and 0.7071. So you multiply that by 28, you have 19.79. Okay, so and when you add together this and this, you have 30, that will give you 41.79 degrees. So that's what you have for that. Okay, so now the question now says to the nearest centimeter. Nearest centimeter means to the nearest whole number. So the answer now is going to be what? 42 degrees. Nearest centimeter. Okay, so that's the answer to that. Yes. Any question based on what we just did now? Any observation? Any observation based on what we just did now? Okay, if there's no question, so that means we'll all understand the explanation. Okay, let us move down to this question here. Let's move down to this next question. Okay, now let's look at the next question. Okay, a chord of a circle of radius 28 centimeter has a length of 28 centimeter. Find the value of A and the distance of the chord from the center of the circle if it subtends 40 degrees at the center. Okay, now look at this question. Yes, can we solve this problem? Does it look like what we can do? Okay, so I want your response to my question. Can you solve it? Does it look like what you can do? If you are making an attempt, let me know. Just drop that in the comment section so I can give you like 2 minutes to make an attempt. Okay. Just read in between lines and see if you can solve the problem. Of course, now it's not difficult. I think we should be able to solve the problem conveniently. A chord of a circle of radius 2a, that is a, 3a, sorry, 3a, we have a there, has a length of 28 centimeters. So you have to find the value of a and the distance of the chord from the center of the circle if it subtend 40 degrees at the center. Okay. Okay. Is Esther dropping an answer? Have you gotten your answer this time around? Yes, Toyosi. Yes. Olawale. Gabriel. Yes. Any answer? Okay. I think we need to solve this problem together because since I'm not seeing any response, so probably you are all waiting for me to solve the problem. All right. So now let's solve the problem together. Let's see. It's not so difficult. But then we just need to apply one theorem. So I'm going to tell you how we are going to go about that. So just pay attention and see how you are expected to solve this type of problem. Now, a chord of a circle of radius 3a. So now let us list all the parameters given. Okay, radius is given to be 3a in centimeter, as a length of 28 centimeters. So we are giving length of chord to be 28 centimeters. Okay, so find the value of A. You have to find the value of A and the distance of the chord from the center of the circle if it subtends 40 degrees at the center. So that is theta is 40 degrees. Can you see that? And pi is the same thing as 22/7. Okay, so now how do we go about this? Now look at the information given. We are given length of chord. So I'll begin to think of formula for finding length of a chord. That will help me now, probably now, to get something out. Okay, so let's try this. So we say length of chord equals to 2r sine theta over 2. Do you still remember this formula? Okay, good. So length of chord has been given to be 28. Just let's plug it in. So we have 2 times r. What is r? R is 3a. So we have 3a sine 40 over 2. Theta is 40. Okay, theta is 40. Okay, so the next thing is to find a way of simplifying. Okay, now let's simplify. I can divide both sides by 2. If I divide both sides by 2, divide this by 2, this by 2. So I will have 14 equals to 3a sine, this is 20, sine 20. Do you understand now? You divide this by 2, you have 14. You divide this by 2, you have 3a sine 20. Okay, so the next thing is to divide both sides by sine 20. Okay, so we have 14 divided by sine 20. That is equals to 3a. Don't forget, we want to get the value of a. So the next thing is to divide both sides by 3 because you are looking for a. So you divide both sides by 3. So now we have 14 over 3 sine 20 equals to a. All right, so once you are dividing both sides by a number, so that number goes to the denominator. Hope you know that. Okay, so this is the value of a. So now let's see, what do we have? 14 over. So check your 4-figure table and search for sine 20, or you press your calculator. Sine 20. What is sine 20? Sine 20 gives you 0.6420. So you multiply that by 3. So when you multiply it by 3, so you'll be having 1.026. All right. So then you can divide 14 by what we have here. Okay, so when you do that, what do you have? Now you have a to be 13.64 in centimeter. Okay, so that is a. Okay, there may not be a need for centimeter again because this is already having centimeter. So if you put centimeter again, so that will be centimeter squared. So a is just 13.64. All right. Okay. Now let's move on. Now the question now says that we should find the distance of the chord from the center of the circle. Yes, that is where we are going to. All right. Now, before we move on, let us get our R. What is R? The radius. What is radius? Radius is 3a. So now let's get the radius. Now I can say radius R equals to what? 3 times 13.64. So R is what? And let's multiply that by 3 times 3. So let's see what we have. So that's going to be 40.9. 40.93 centimeter. So that is the radius. Okay, so we now have the radius now. Since we have gotten a, so we have the radius to be this. So now let's now get the distance between the center of the circle and the chord. The chord. Okay, so now the circle is like this. So this is the center of the circle. All right, so we have a chord. Now, can you see the chord now? Okay, so now let's see. We want to get the distance here. Don't forget this is 0. Now, the length of the chord has been given. So from here to here is 28 centimeter. That has been given in the question. You can see that. All right. So, and the radius is also known now. So this is the radius. So you can bring down the radius down to this place. So radius is 40.93 in centimeter. Okay, that's in centimeter. Okay, so now we want to get this distance. Let's call this place M. M. Now, the theorem that we're going to be using now says that if you draw a line such that is perpendicular to a chord, that line is going to bisect the chord into two equal parts. So now this line now is drawn down such that it's perpendicular to the chord. So if it is perpendicular to the chord, what the theorem says now is, now this line will bisect this chord into two equal parts. So that means that this side, let's say this is AB now. So AM will be equal to MB. So they'll be equal. So that means MB will be what? Will be 14 centimeters. All right. So that will be 14 centimeters. So, and then we can now get this height, the distance between the center of the circle and this circumference, the chord, sorry. So now let's represent this with x. That is the distance between the chord and the center of the circle. We can represent that with x. So let us get x now. So can you see, what are you seeing now? Can you see a right angle triangle? All right, right angle triangle OMB. So now we have the two sides, 14 centimeter and x, and the hypotenuse, which is 40.93. Okay, so let's use the Pythagoras theorem. So if you square the sides together, it's going to be equal to the square of the hypotenuse. So we have x squared plus 14 squared equals to 40.93 squared. Okay, so now you have x squared equals to 40.93 squared minus 14 squared. Okay, so x squared equals to, can we square that 40 point, we have 40.93. So when you square that, what do you have? Okay, so you have 1675.26 minus, when you square 14, you have 196. Okay, all right. So x squared, so let's take this away. So minus 196. Okay, so what do you have? You have 1479.26. Okay, so we can take square root of both sides. So when you take square root of both sides, let's see what we have. So we have x equals to square root of 1479.26. So x equals to what? So let's take the square root of our answer. So we have 38.46 centimeters. So that is going to be the distance between the center of the circle and the chord. So it's going to be 13.46 centimeters. All right. I hope you understand that. Okay. So based on what we have just done, any observation, any question? Yes, if you have any question, you can drop that in the comment section. Any question based on what you have just done now? Okay, I'm not seeing any response, so I don't know why you are not responding today. Probably maybe because of the network or so. Okay, so no problem. So if there is no question based on what we have done, so that means we may have to end the class now because we spent a lot of time today. So I want to appreciate every one of you, those of you that joined me yesterday for the class, and you are back again today. I really appreciate you. And those of you that are joining us for the first time, so you are also appreciated. You are welcome to the class. And don't forget, if you are new on this channel, ensure you click on the subscription button. If you are not new, every one of you should also tap the like button if you love what we are doing here. Okay, so yes, later today we are going to do a recap of what we have done in the morning. Okay, so we are going to see you soonest. So take good care of yourself. Bye bye.